Hello and welcome to AP Stats, the end of Chapter 2, and we're not going to have an official quiz over this because it's been quick. We're going to move into Chapter 3, but here is the end of Chapter 2. It's the end of displaying data, and we're going to talk about bivariate numerical or quantitative data and some common mistakes. So the first thing is the scatter plots. You're just plotting x against y like you would in, like, say, an algebra class. On the x-axis, you want to make sure that you have your independent variable. Think of it like that. Here's an example. This is cost of shoe versus rating of the shoe. And would you expect there to be a correlation is the correct word here. Would you expect there to be a correlation between the cost and the rating? I would say probably. You'd probably say the more the shoe costs, the higher the rating. So that would be called a positive correlation, as in x increases, and so y increases. As cost increases, quality increases. So you'd think that rating, you'd think there'd be a correlation there. So this was taken from a Consumer Reports, and here, go ahead and plot the scatter plot. So pause the video and plot those points, x against y. There it is, and it's interesting. So the question is there a relationship between x and y? And looking at these scatter plots here, there's really not much of a relationship, but you do notice that, I mean, these are kind of clustered here, and these are kind of clustered up here, which kind of means that the more the shoe costs, the lower the rating. And if you could, you could attempt to do a line of best fit, right? Something like that. Possibly, kind of. We have a whole chapter about line of best fits and that sort of thing. That's the last chapter actually we do. But if I were to look at this and I were to buy a shoe, I'd probably want to buy this one. It's got a pretty good rating, and it's only $40. Wait a minute, where's that shoe? Anyway, it's one of these. Maybe it's 45. It's just a little off. My plot's not perfect, but anyway, I'd probably buy that one, and then this one is. This one's no good. That's not a good shoe. Costs a lot, low rating. So is there a relationship between x and y? Possibly a negative relationship, meaning as x goes up, y goes down. That'd be a negative relationship. As the cost increases, the quality decreases, which is interesting. The next thing is a time series plot, and you're just plotting points as time increases, and that's pretty much what it is. You can and notice here that this didn't start at 0. It started at, say, 45, and then 50, 55, 60, and that's okay. But a lot of times you'll see like something like this, which will kind of tell the reader that it doesn't start at 0. And same thing down here. So you might see that little notation like that. It means it doesn't start at 0. Time series plot. Like I said, here's an example. This is the Christmas price index. Pause the video and read through this. The Christmas price index. It's the price of giving all the gifts of the popular song, the 12 Days of Christmas. And it's hard to read, but that's 1984. And here's 2019. You can see that they took a dip right here, which is interesting. Describe any trends or patterns that you see. So we could say overall it's a positive trend with a little bit of decline right about there. Around 1993 to 1996, somewhere in there, there's a decline, and it hit its minimum, and then it was pretty much a positive trend since. So Just writing something like that. The next, we're all familiar with the pie chart. Each represents a percentage of the whole. You just take 360 degrees and multiply it by whatever percentage you need, and then that's your degree that you get. Here's the Fred Flintstone Life and Health Insurance Foundation. Each person surveyed was asked to select which of the 5 fictional characters had the greatest need for life insurance. So, of these, which one needs life insurance the most? And the survey came back with Spider-Man needs life insurance the most. You might not agree with that. I would say Marge probably needs the most. Actually, Fred probably needs the most because he's the caregiver. No, what is he? He's the worker in the family. He probably brings home the most money, and if he dies, the family's going to be out of luck. So he would need life insurance. Anyway, that's not the point here. Moving on, a segmented or stacked bar chart. It's basically a pie chart, just as a bar. It's and so you put the 0 to 100% here on the axis, and then you put the categories here, and then this represents whatever percentage you need it to be, like a pie chart. Alright, so over to the side here, this segmented bar chart summarizes students' response to the question during the past year. How much time did you spend studying and doing homework in a typical week? Okay, probably not the best example here, because shame on you, Higher Educational Research Institute. You think that the students are going to respond correctly here? Probably not. Call it a response bias. So anyway, whether or not this is good data is not the point. The point is that this is a segmented or stacked bar chart. And we can see that the majority of students are 6 to 10 hours, even though the color is not there exactly perfectly, but the majority of the students are 6 to 10 hours. And that would be roughly 10, 20, about 30%, a little less than 30%. You can kind of see that on the edge here, about 30% fit in there. Alright, if this was class, we would now kind of split up and we'd talk about what was going on with these charts. This is now the end, and we're going to figure out what's misleading about these charts. So what I want you to do is pause the video and just ask yourself, what is misleading about these charts? And we are back. Alright, here's the first chart. The average number of cows milked in the U.S. dairy farms continues to climb, and you can kind of see that. And it's almost like a perfect step up according to this graph. There's one cup of milk, 2 cups of milk, 3 cups of milk. So what's misleading about this graph? Even though this is 1 cup of milk and this is 2 cups of milk, 32 is not double 19. Okay, so they got fancy with their graphics, but their graphics don't really represent perfectly what's happening here. So that's probably not the best way to do that. You could like cut a cup of milk in half. Maybe that would be better, so that it's proportional. Let's see here on the back. I've got example 5 for the cow milk graph. Areas should be proportional to the frequency. Please pause the video and read through the rest of that. Next, example 6. Let's take a look at this. What is wrong with this? So apparently somebody did a study and they surveyed people that took a traditional experience. They did a pre-test and a post-test. And these scores are pretty close. And then they used their amazing tutoring software, whatever it is. They took a pre-test, and look at the success on the post-test. Wow, that's almost triple. They almost tripled the results. That's what this graph would tell you. However, this starts at 50. So while it looks like it's tripled, really it's going from a score of 55 to somewhere in the high 60s. So it's not tripled. So it looks like it's tripled. This looks about 3 times as tall as this, but really, if you look at the axes, that is not the case. So that would be this one. Be cautious of graphs with broken axes. You can have broken axes, you just have to be cautious. The use of broken axes in scatter plots does not result in a misleading picture, so we saw that here. Okay, you're still going to have a negative correlation regardless of where you start with scatter plots. However, with bar graphs, it is never a good idea. In time series plots, broken axes can sometimes exaggerate the magnitude of change over time, so you have to be careful with that. And in bar charts, vertical axes should never be broken. That'll give a misrepresentation of what's happening. Alright, next. Example 3. You've got 1%, 1%, 1%, 1%, 4%, 8%, 82%. And I mean, really, this might be proportional, but it's just really hard for the reader to kind of understand what's the magnitude of this. Like it would be going up through the top of the paper if this was just a regular bar. So, for example 7, that would be error number 5. We're going to call it. Make sure that your graphical display creates the right first impression, and that it's easy to read. Number 8, example 8 here. If you look, this is a time series plot here, and this looks really good. If I was a banker, number using online banking in millions, we'd say, wow, look at that. There's a very positive trend. And that, but then I'd look closely and say, why are the dates all weird? Why aren't these equal dates? Because maybe what's happening is someone's trying to hide something when really, so you got this point and this point, and really what happened is you went like this, you know, and you'd never see that because you don't have equal intervals. So when you have equal intervals, it kind of takes care of stuff like this. The more points, the better for the time series plot. Let's see, example 8. Let's see. Example 8. Watch out for unequal time spacing in time series plots. And that's that. You can read over that. And the last one is example 9. This is interesting. Here's a plot, and this is a scatter plot, so it's okay that we don't start at 0. That's okay. We still see a nice relationship, and it's nearly perfect. It's nearly a perfect line, so a perfect relationship. And what are we looking at? We're looking at the number of Methodist ministers and the number of barrels of imported rum. Huh, that's interesting. So you're telling me that as the number of ministers increases, the number of barrels of rum increases. So you might be tempted to make the conclusion here that by bringing in ministers, that causes barrels of rum to be imported. So how can we account for this? Let's see here. This would be our last one. So here, be careful how you interpret patterns in scatter plots. Ugh. Patterns in scatter plots. Example 9, scatter plot shows the relationship between the number of Methodist ministers in New England and the amount of Cuban rum imported into Boston from this time frame, and it has almost a perfect R value, which we'll talk about again. This is the last chapter, we'll talk about these. So the question is, does an increase in ministers cause the increase in imported rum? And probably not, but what a scatter plot does show, what a scatter plot does not show is cause. You can never take a scatter plot to say something causes the other. You can say they're correlated, or you can say that the two variables tend to vary together in a predictable way. That's what you can say. So once again, you can say that the two variables tend to vary together in a predictable way, but this does not show a cause and effect relationship. You can only show cause and effect relationship with a well-designed experiment. Alright, so your homework is these 3 problems, and then the multiple choice at the end of the chapter. There will not be a quiz next class. I'm sorry. We're going to do something a little different for the assessment for this. Alright.